Example 3. If p is a real number, show that the following sequence cannot be geometric. 2, p minus 2, p minus 7. Solution. Consider the given sequence. We assume that the sequence given in the question is a geometric sequence. Then, we will determine the possible values of p. If p turns out to be a real number, then our assumption is valid. If p is not real, the assumption is wrong, and therefore the sequence is not geometric. In a geometric sequence, we know that the ratio of any two consecutive terms is constant. Therefore, p minus 2 over 2 equals p minus 7 over p minus 2. Cross-multiplying, we get p minus 2 to the power 2 equals 2 times p minus 7. Expanding the terms, we get. Recall the formula for obtaining the roots of a quadratic equation. Here, a equals 1, b equals negative 6, c equals 18. Substituting the values for a, b, and c, we get. Therefore, p equals 3 plus or minus square root of negative 36 over 2. The values of p calculated from the quadratic equation are non-real, since the square root of a negative number is not real. This means that for the sequence to be geometric, the values of p need to be non-real. So we can conclude that if p is a real number, the given sequence 2, p minus 2, p minus 7 cannot be geometric.
Need more help? Subscribe to our channel. Can't wait that long? Ask Masky to help you and let the math finally start mathing.